Welcome back, guys. Today's video is going to be covering Lewis structures. It's really important that you're able to go through and follow the steps to successfully draw a Lewis structure for a given molecule. Now make sure to check out my other videos on formal charge and resonance structures to help you with Lewis structures. However, in this video, I'm going to be going over the basics so you can have an idea of how to draw a Lewis structure successfully. So in this video, I'm going to start with the practice problems and work backwards following these steps to make sure we know how to do this process correctly. So to draw the Lewis structures for the following molecules, we're going to start with our CF4 molecule. So that's going to be a carbon with 4 fluorines. Now step 1 says to add up the total number of valence electrons in that molecule. So we have C, we have 4 fluorines. To add up the total number of valence electrons, we can use the periodic table. If you're unsure how to do that, check out my video on valence electrons. So carbon's going to have 4 valence electrons. There are 4 fluorines. Each fluorine has 7 valence electrons. So 4 plus 28, we're going to have 32 valence electrons to work with. So let's go to step number 2. Step number 2 says choose a central atom. Now it's really important that you can choose a central atom. This is something you're going to get better at with time as you keep drawing these out, doing more examples, right? So how to choose your central atom. Here are some tips that you can use to help you decide what atom is your central atom. So hydrogen is never going to be the central atom. So when you have a molecule, we don't have hydrogen in this molecule, but if you have hydrogen in something like NH3, hydrogen's never going to be your central atom. So that is a good tip to follow. Now I really like this second tip. The unique atom is likely the central atom. So if you have something like NF3 or CF4, we see that there is 3 fluorines and 1 nitrogen in this molecule, right? So the unique atom is nitrogen here, right? There's 3 of these fluorine atoms and there's 1 of these nitrogen atoms. That's the unique atom, right? So we would likely put that in the center of the molecule. Now over here, we have 4 fluorines and 1 carbon. Carbon is our unique atom there. So I'm thinking carbon's going to be our central atom. Now let's keep going through some of these tips. It says carbon will be the central atom unless stated otherwise. So this is a really good rule of thumb that I like to use. Unless you're dealing with a molecule where they say not to put carbon in the center, carbon is likely going to be your central atom. So these 2 tips are pointing towards carbon being our central atom here. Lastly, if you still can't decide what your central atom is, the least electronegative atom is the central atom, right? So electronegativity, we know that electronegativity increases as you move up and towards the right of the table. So atoms like fluorine and oxygen are going to be the most electronegative atoms on the table. Now, a rule of thumb, oxygen is more electronegative than carbon, which is more electronegative than hydrogen, right? So these all point to carbon being our central atom, right? It's the unique atom, it's probably going to be in the middle, and it's actually the least electronegative atom in this molecule because fluorine is more electronegative than carbon. So now that we've decided our central atom, what we're going to do is we're going to complete the octet of each atom using covalent bonds and lone pairs. So let's actually break that down a little bit more and come over here and draw this Lewis structure out. So we've decided that we have carbon as our central atom. What we want to do is bond each fluorine to the carbon and then go from there. So we have 4 fluorine molecules attached to the carbon. Now, what do these lines represent? These lines represent covalent bonds, right? Over here it said that we're going to complete the octet of each atom using covalent bonds and lone pairs. So covalent bonds are these bonds right here which connect 2 atoms together, and they actually represent 2 electrons, right? So we can think of each one of these bonds as 2 electrons, right? And a covalent bond is the sharing of electrons between 2 atoms, right? So let's see if we can go through and fill in the rest of these electrons. Now, it also says we have to complete the octet of each atom. So each atom has to follow the octet rule. And the octet rule says that each atom should have 8 electrons in its outer shell. So, have we completed the octet for carbon? It looks like we have, because we have 2 electrons, 2 electrons, 2 electrons, and 2 electrons, right? So if you add all those up, there are 8 electrons in this carbon atom. So we have completed the octet for carbon. So carbon is all set with its octet rule, right? Now, what about the fluorines? The fluorines are not going to make any more bonds to carbon, right? Carbon is done making bonds. It has its octet. So once you've made 4 bonds with carbon and it has its 8 electrons, you're all set with that carbon atom. Now, what about the rest of our valence electrons? Because we've used 8, right? We've used 8 electrons, but we have 32 to work with. So if we subtract 8, right, what are we going to have left? So that's going to be 24 valence electrons left, right? 24 valence electrons remaining that we can work with, right? So where are we going to put those? Well, what we're going to have to do is use lone pairs to fill in the rest of our electrons, right? We're done making covalent bonds, right? Carbon's done. However, we have 24 electrons that we can use to complete the octet of each fluorine atom. So each fluorine is going to need 3 lone pairs. Now, lone pairs are not shared between atoms. They are on specific atoms, right? They're not shared. So if we put 3 lone pairs, right, and each dot represents an electron, right? So 2 electrons, 4 electrons, 6 electrons, right? We can see that fluorine's octet is complete here because it has 2 from this bond and then 4, 6, 8 from the 3 lone pairs, okay? Now let's do the same thing for each fluorine, giving it 3 lone pairs, okay? So let's see if we have completed the octet for everything and we have used up all of our valence electrons, right? Everything seems to have completed its octet. Everything has 8 electrons, and we've used up 2, 4, 6, 8, right? And then each fluorine has 2, 4, 6. So 6, 12, 18, 24 electrons are used up for lone pairs, right? And then if we count up these bonds, it would be 26, 28, 30, 32. So we have successfully used up all 32 of our valence electrons, and we'd be done for that CF4 molecule. Now, let's erase this and work on our next molecule. So make sure you pause this and make sure that you can go through and do this on your own. I'm going to erase it to give ourselves some space here. Okay? We're going to follow the same set of steps for our next 2 molecules. Okay? So we have NH3. So for NH3, let's follow the same steps. So we're going to add up the total number of valence electrons. So we have N, we have 3 H's. Now nitrogen has 5 valence electrons, and each hydrogen, right, there's 3 of them, has 1 valence electron. So 5 plus 3 is 8 valence electrons, right? So step 1 is done. Now we're going to choose a central atom. Now our first tip says that hydrogen is never the central atom, right? So we're going to put nitrogen in the middle. However, we can also use this tip. The unique atom is likely the central atom, right? If there's 3 hydrogens and only 1 nitrogen, nitrogen's kind of, that unique atom in that molecule, so we're going to put that in the center. So let's go over here and put nitrogen in the center. I'm going to put 3 hydrogens bonded to this nitrogen, right? So we have 8 total valence electrons to work with. How many have we used so far? So we have 2, 4, 6 that we've used. So we only have 2 valence electrons left to work with. So we've used up 6. We only have 2 left to work with. Now, hydrogen is the exception to the octet rule, right? We said that everything needs the 8 valence electrons. However, hydrogen only needs 1 bond, right? So once you've made 1 covalent bond to hydrogen, hydrogen is all set. You don't need to add anything else to it, I should say. So we have our nitrogen. The hydrogens are all set with their octet. We only have 2 electrons left. Now what do we need to do? Nitrogen has 2, 4, 6 electrons. It needs 8 to complete its octet. So what we can do is put those last 2 electrons as a lone pair on the nitrogen, right? So now nitrogen has 2, 4, 6, 8. It's all set. The hydrogens are all good. So now we have completed this Lewis structure for NH3. So let's take a look at our last example and see if we can go through that one. So our last example is CH3OH, okay? So the total number of valence electrons here, we have 4 plus 3 times 1, right? 4 for carbon. There's 3 hydrogens. Each one of them has 1 valence electron, plus oxygen, which is 6, plus this last hydrogen of 1. So we've got 4 plus 3 is 7, 7 plus 6 is 13, and 13 plus 1 is 14 valence electrons, okay? So now let's choose a central atom. Okay, now one thing with Lewis structures, right, if you see something written in this way, you can usually use the fact that it's written correctly from left to right to decide what is bonded to what. So if you see it written like this, CH3OH, what we can imagine is that this carbon has 3 hydrogens bonded to it, most likely this oxygen to complete its 4th bond. This hydrogen over here is most likely bonded to this oxygen. They're pretty nice when they write these out. They give it to you written in the way that you should draw it out as, you know, written left to right, right? So you can use this left to right rule to say, okay, I think the carbon's going to be bonded to these things. This hydrogen is going to be bonded to this oxygen, okay? So let's choose our central atom. So I'm going to use the tip that carbon will be the central atom unless stated otherwise, right? It kind of points to the fact that carbon, right, if it's in a molecule, we're going to put that in the center and see where we go from there. So let's put carbon, right, and we know hydrogen's never going to be the central atom, right? And if we're confused between oxygen and carbon, well, oxygen's more electronegative than carbon, so I would say the least electronegative atom we should put in the center. So we have carbon in the center. We have 3 hydrogens bonded to it, and it's CH3OH. So carbon needs 1 more bond to complete its octet because it needs 8 electrons and it only has 2, 4, 6. So what we're going to do is put that right there, right? And now this hydrogen is bonded to this oxygen. Now let's see how many valence electrons that we've used. We've used 2, 4, 6, 8, 10, right? So we've used 10 valence electrons. We had 14 to start. We have 4 remaining. Now let's see what we need to do to complete the octet for each one of these atoms. Now hydrogen is done, right? We only need to make 1 bond to hydrogen. Carbon is done. We've used 8 electrons for it, right? 2, 4, 6, 8. Now oxygen only has 4 electrons right now. So we need to give it 8. So what we're going to do is put 2 more lone pairs on the oxygen, right? We don't need to make any more bonds to this carbon or this hydrogen, right? Because their octets are already full. So we can only put lone pairs on there, right? We've used 2, 4, 6, 8, 10, 12, 14 total valence electrons, which is perfect, and everything has its octet. So hopefully this video was helpful in going through and drawing out Lewis structures. Make sure to check out more videos on the channel.